Okay, everyone, so this is where we're picking up on DNP presentation part 2. I thought I was only going to be having 2 parts for DNP, but as it turned out, as long as that last one was, I'm going to break it into 3 parts now. So this will be a fairly short presentation, but this is the presentation on communications, and then we'll go into message structure as the 3rd part. So when we're looking at this this presentation on communications, what we're talking about is polling schemes, and then we'll talk a little bit about unsolicited messages, just so you can understand how a network with DNP that uses unsolicited messages is formatted. But in general, at least in power systems, unsolicited messages in a quiescent network are something that you're really not going to see, because we're looking for a little bit higher integrity to our connections and our real-time data. So in some cases, unsolicited quiescent networks are the way to go. And in gas, I saw a lot more of that decades back or years ago. Anyhow, when we're talking about polling schemes, one thing probably to understand at this point in time is that when it comes to these polling schemes, these polling strategies, if you will, as another way to say it, is really based around our class data types or data objects. And if you were to look in your object library, and if you were to look at the very last table in the object library, which is object 60, so object group 60, if you look at that, and remember, this is a hex number, just so we know. So this is object group 60 as a hex number. When it comes to the object 60, it has 4 classes. And the class 0 is all of our real-time or static values. So it's an overall general data type that's saying what is all your real-time or instantaneous values of any point. So that's class 0. When it comes to class 1, 2, 3, these are changes that have occurred in any of our class 0 values. So it's what's called events generated from these class 0 points. So that can be a change of state for a binary going from 0 to 1 or 1 to 0. It could be a deadband change for a counter. So a counter is increasing in value, and once it reaches this value, it's exceeded its deadband and it reports an event. When it comes to an analog value, that's a value within a threshold that if the analog stays within that value, everything's good, but it creates an event if it exceeds that threshold or that deadband. So this is really the class data, it's called, that's a very important data object. And what makes it really important is because we can leverage the general data type object like this when we build a polling strategy or a communication strategy to, again, being a true SCADA protocol, DNP is out to maximize the use of its bandwidth, to really be efficient with the data connections that it has, because in turn, if it is, then it can have far more real-time data. That is to say, it doesn't have latency and delays in retrieving that value, and it gives the head engineers and the operators of the larger system an accurate and real-time picture or snapshot of what's going out over a wide, or what's going on in a wide area network. So that's really the idea behind all of this, which includes the class data objects, but also the configuration of the communications and how the polling scheme will be set up. So when it comes to our polling options or our polling schemes, these are some of the polls that are, and when we say polls, this is essentially a request going out from the master that's configured with some of these class data objects in them. And the first one is just understanding what's called an integrity poll. And if we were to look at our object library, we would see that this integrity poll is one that includes all events and all real-time points. So notice how it says master requests all of the events, all of the changes, and all of the static data. We know static data stands for real-time data. So this is really saying, tell me everything that you have, both as events or real-time values. So it's a full snapshot, if you will, of the remote location. Now if you look at the next one, this is an event poll only. So this is a class 1, 2, 3 poll, and this is the one that just simply reports or asks the remote device or the server, do you have any changes? And then there's a response based on whether there's changes or not. And you can see how with only event polls, it would really improve the efficiency of your wide area network because you're not like Modbus repeating the same thing over and over again and using bandwidth when there's really no difference in the picture or the snapshot from one poll to the next. So this is called an event poll, and it would be defined specifically as a class 1, 2, 3 data poll. So then the last one is one that involves unsolicited messages from the remote or the outstation or the server. Now when it comes to unsolicited messages, what we need to understand is we can have polled URBE, it's called, or we can have unsolicited URBE. Now they both involve unsolicited messages, but one of them includes some regular polling, while the other one is only report by exception messages. And that's what RBE means, by the way, if you don't remember some of the terms from, say, some of the previous videos. RBE is report by exception. So there's two types, one called polled RBE and the other called unsolicited. Polled RBE is essentially combining a regular polling sequence with unsolicited messages. Unsolicited is simply like it says, it's only shout outs from the outstation when there's something to be reported as an event or a change of state. So then of course the last part is where, and I'm not going to bother erasing this, guys, sorry, but in the last part is where you have specific data polling. So this is where you call on a specific object, like an object 1 for binaries or an object 30 for analogs and so on. And this would be like Modbus, right? So specific data polling would be Modbus. Whenever Modbus is sending a request, it's sending a request to read or write a specific data type, as you know. So if we take a look as an example, here we have an outstation. I'll use the DNP terminology for that. We have the outstation here, and at the outstation we can see we have both its static and event, static and event database. So I'm just going to kind of draw a line here and say up here is all real-time. This is the real-time database. Down here, of course, is your event database. Now, as it stands right now, you can see in our event database that includes class 1, 2, 3. In our class 1 event buffer, we have 2 events, event 1 and event 2. In class 2, we currently have no events. And class 3, we have an event categorized as E3 or event 3 here. When it comes to our real-time values, we have a whole list of binary inputs, okay, all seen here in a binary input table. and our analog input values that are real-time values shown from 0 through 4 and 0 through 4 for our binary inputs. So if we look at the different poles that our DNP master is capable of in terms of these class and data objects, the first one that we would look at is this integrity pole. Now if you go back to that slide, remember that integrity pole is a class 1, 2, 3, 0 data pole, which class 1, 2, 3 is all the events, and class 0 is a real time. So what does that mean? That means when the integrity pole goes out, we're first of all going to be retrieving the events. So we can see that class 1 has 2 events. That means they're going to be transferred via response back to the master, and the master will be able to load all the events. Now remember, there was no class 2 events, but there was a class 3 event. So all of that information is being reported back to the master, and then now the master is going to populate its event server with the values from that specific outstation because of the integrity pole. Then the last part of it is to retrieve the real-time value, and that means that the binary inputs will be reported back as their specific object group and variation, and the same with the analog inputs. They'll be reported back as their specific object group and variation. And now we'll have all the values in the real-time database corresponding to that class 0 part of the integrity pole. So that would be an example of a class 1, 2, 3, 0 pole. If we look at just an event pole, that means it could be class 1 and 2 and 3, or it could just be only class 1, only class 2, only class 3, and so on. So I think you can see clearly that if we were to send a class 1 data pole, we would retrieve 2 events. A class 2 data pole, the response would be no events to report, and then class 3 we would have 1 event coming back. So the event pole is simply a 1, 2, 3 a class 1, 2, 3 pole. Now it could just be 1 though. You need to realize that an event pole is not always all the classes 1, 2, and 3. It can just be looking for the most important events categorized as class 1, and the protocol allows you to assign your classes of events based on your priorities. Okay. So then this next one, which I'm going to talk about in a minute, I'll kind of put it aside for now, but this is unsolicited messages, where there is no actual polls going out from the master, and it's only when events occur that the remote or the outstation is going to, I call it, shout back its significant event back to the master, and it's unsolicited. And when it says unsolicited, it's saying that it wasn't requested by the master. So that's called unsolicited responses. And then of course we have the last one we talked about, which could be a specific data poll. So in order to retrieve these real-time points as binary inputs or analog inputs, you'd have to call on the specific object group number. And obviously it's variation 0 as a wildcard would give you whatever variation is included in the configuration. So let's say we would then, for a specific data poll, let's say we would send out object 1 for our binaries. Object 1, variation 0 would be the wildcard saying give me back whatever you have. And then for your analogs, you could do object 30 as our analog input object group number, and then you could do variation 0 there as well, which is going to say give me back whatever specific variation you've been configured for, meaning the outstation. Okay, so hopefully that gives you a better idea of how these different polls integrity, event, and specific data polls can be used in your polling schemes, in your essentially your communications configuration of how you're going to leverage these class data polls. Okay, so really when we look at just doing another comparison between DNP and Modbus, Modbus not being a true SCADA protocol is going to be polling like this all the time. So if you had a wide area network with Modbus, you can see how you would be really, I guess, wasteful with your bandwidth, because there'd be a request going out every time for all the real-time data. And remember, each time you have a new data type, you would have to send a different request. So if you had 3 different data types, that would mean there'd be 3 requests each time you came around to polling it, and 1 for each data type. And you can see how that would use a large amount of bandwidth and be wasteful. When you compare that to DNP3 as a true SCADA protocol, we're using the efficiency of these class object groups like class 1, 2, 3 as only changed values to be reported. So I can send out a request for event data only, and then I'll only have changes being reported back, right? And let's say there's no changes, or let's say there is changes, doesn't matter. Whether there's no changes or has been some changes, the master just follows up with an acknowledgement at the end. And that's what you see here, is an acknowledgement to say, okay, I've received your events, and now you can empty your event buffer and load it with new events when they occur, because my event database has now recorded whatever events have happened at that outstation. So you can see how this is far more efficient, because in most cases there's probably no events, and specifically no events in class 1. And so if you just regularly went around and asked for class 1 events, and then came around to class 2 events less often, and then class 3 rarely, you're really maximizing the use of your bandwidth. Every time you come around, you use class 1. The next time you come around, you either add class 2 into it, or only do class 2, say, hourly, and class 3 twice a day, and so on. You get the idea. This is where you can use class data and your polling scheme to really be efficient with your... Okay, so carrying on with that, then remember, class 0 is our instantaneous values. That's really a limitation of Modbus. It can only work with what is class 0's equivalent, and that is just all of the real-time or static values. When it comes to DNP, of course, what's unique is that we can use our class 1, 2, 3 data polls and just get event data. So what it means is that at the outstation, we have an assignment for data in a class. So some binary inputs are going to be in class 1, things like breaker trips and things like that. For other binary inputs, which would be less important, you could find them in class 2 or 3. So one thing to understand, though, too, is any data that's going to be in class 1, 2, or 3 has to be in class 0, right? So there's no doubt that it has to be a real-time point that's changing, like a class 0 point. And it says class assignments are configured in the outstation. Okay. So this would be our example of where we have a regular check of the remote using class 0. So this is where we want to update our real-time database and make sure all of our points are online, but we don't need to do that every time we pull that device. So what we would have is regular class 0 updates, just to make sure all of our real-time database is in sync and online. But this would happen rarely during our polling sequence. But of course our events is what really matters, so we would poll for event data frequently, right? So every time we pull that device, we'd be looking to see if there was any events or important changes of state. But every say, you know, maybe 4 times a day, we would look at just synchronizing or updating our real-time database by doing a class 0 data poll. So lastly, I'm just going to talk about report by exception here, RBE, and then I'm gonna leave it at that. But when it comes to report by exception, remember we have 2 types. We have unsolicited, or URBE, and then we have PRBE, which is polled report by exception. For unsolicited RBE, like what we see here, it means that we essentially have a quiet network. And the network is, there's no communications going on until such a time as the outstation now wants to initiate communications. Notice how it's complete opposite of what we're used to with our polling. And it's always the master that initiates communications in a polled scenario. But here with URBE, it's just the outstation that's initiating communications whenever there's an event. And then the outstation is the one that's initiating communications by sending a event back to the master, and then the master acknowledges the receipt, or acknowledges the fact that it received those events and allows the outstation to clear its event buffer. It doesn't send any RBE values, or it doesn't send any event values until such times it has more events. So you can kind of get the idea there. And I don't spend much time talking about that, because in power systems you don't see this scenario. So really, when it comes down to DNP's modes for retrieving data from an outstation, you can have polled static, which is really the real-time database every time, just like Modbus. You can have polled report by exception, where we are regularly checking for events every time, but we occasionally look for real-time data just to synchronize our real-time database. And then you can have that URBE that I just talked about, where it says the communications is unsolicited, and every once in a while you'll have an occasional integrity poll. Okay, now this, it kind of almost looks like it's the same thing, but the difference is that in polled report by exception, we're polling for event data, and then in the second one, communication is only when there's events, right? So this with polled report by exception, the network is never quiet. There's still a continuous polling of class 1 for sure, and possibly class 1, 2, 3 every time. Now this is the last one, where there is no occasional class 0 integrity polls, and it's just a completely quiet network. And that's the only time there's communications is when there's an unsolicited RBE. Okay, so that's called the quiescent example, where the network's quiet. So next presentation, we're going to go into message structure here, and that'll be our third and last presentation on this. So yeah, we'll call